Okay, so let's start talking about internal resistance and terminal voltage. This is the circuit that's in your notes. This is the battery. On the battery, it's stamped 18 volts. That is your electromotive force, your EMF. Okay? But inside the battery, there is a little internal resistance. And so that means that technically we never get 18 volts coming out of the battery. So we can go ahead and take a look at this first question. The first question goes ahead and tells me that the terminal voltage is going to be 15.84 volts. So that means I get 15.8 volts, okay? And then I am told that the current flowing through the circuit is 4 amps. Okay. So the question number 1 in your notes says, calculate the value of the internal resistance R of the battery. Well, the formula you are given is that the voltage of the terminal equals the EMF minus your IR of the internal resistance. Okay. So therefore, I can go ahead and rearrange that equation because I'm looking for, the question asked me to find this little r. So I can say r is going to go ahead and equal the EMF minus the delta V, the delta voltage, the change in voltage of the terminal divided by the current. So if we fill in some numbers, I can see the EMF was 18. It tells me in the story that I have 15.8 volts as my terminal, and I need to divide that by 4 amps. So that gives me an internal resistance of 0.55 ohms. Part 2 of this question goes on to say, well, what is the resistance of the external resistance? Well, we know that resistance is going to be the V of the terminal divided by the current in the circuit. Well, that is my 15.8 volts divided by 4 amps is going to give me 3.75 ohms. Okay. Right, the next question is based on your graph. Let me go ahead and get a blank sheet of paper. There we go. So this question says that you have an external resistor, it's connected to a battery, so it's just like the little diagram up above. And what it wants you to go ahead and do is use the graph to figure out what the battery's internal resistance is going to be. Well, part 1, you need to know that the internal resistance is going to equal the magnitude of the slope. How do I know that? Well, I know that because R equals V over I, which in this case is my delta Y over my delta X. So when I look at it, when I read my graph, I have got 2 points. I have got a point that I would like to use. It's at 3 amps and 30 volts. And then I have another point that is on the grid, and that is 6 amps, and that is 24. Okay, so when I go ahead and calculate out the resistance, I am going to get 24 minus 30 divided by 6 minus 3. 24 minus 30 is negative 6. 6 minus 3 is 3. So technically, my slope is negative 2. But we would never ever talk about a negative resistance. So we're going to go ahead and say the internal resistance R is going to be 2 ohms. So that was question number 1. Right, question number 2. Question number 2 says to us, use the graph to figure out the EMF. Well, this is a straight line. So we know that we've got a mathematical relationship that says y equals mx plus b. Y is your voltage, your m is your slope, which we've just calculated as -2. The I is going to be your x, and then we've got this plus b. Okay, so EMF, the definition of the EMF is the voltage when no current flows. Okay, therefore, if x equals 0, if x equals 0 amps, then the graph can give us the voltage is going to equal your B, and that B is your y-intercept. Okay. Now, if I look at my graph, I don't have the y-intercept, and it's not accurate enough just to go ahead and extrapolate it back. So let's go ahead and let's use some math. Well, we can pick a point. The point I am going to go ahead and pick is the 30 volt point. So I can say 30 volts equals -2. What was my current at 30 volts? My current was 3 plus the y-intercept. So now I end up with 30 equals -6 plus b. Therefore, my y-intercept must be 36. And if my b is, therefore, I can go ahead and say the EMF must equal 36 volts. So let's just back up and take another look at that. First and foremost, we discovered with a straight line, you know from math, that y equals mx plus b. The y in this particular graph is the voltage, the x is the current. By definition, the EMF is the voltage when no current flows. So if x is 0 amps, therefore the voltage is going to equal the y-intercept, which is b. So I picked my point, 30 volts and 3 amps, worked through the math, and I ended up with my EMF of 36 volts. Okay, so now we get on to the next part. Okay, so part number 3. So part number 3 says, for what value of R is the voltage equal to 50% of the battery EMF? Well, 55% of 36 volts is going to equal 19.8 volts. We know that the resistance is going to be this terminal voltage all over I. So we can say the R is going to be this 19.8, but wait a wee minute, we don't know what the I is. So let's do a sidebar. How can I find I? Right, well, again, we have got this formula, it's a straight line, y equals mx plus b. So in other words, we can say the voltage is -2 times the current plus the B. So if I put in my voltage that we need, which is 19.8, -2 times the I plus your 36 from your previous question. So I can now turn around and say 19.8 equals negative 2I plus 36. Rearranging the equation, I can go ahead and get negative 2I equals 19.8 minus 36. So negative 2I equals negative 16.2. So my current is going to be 8.1 amps. Okay, so that's just using the equation for the straight line, substituting in the 19.8 for the terminal voltage and the 36, which was the EMF, and working out the current. So then I can come back up to here and I can stick in the 8.1 amps. 19.8 divided by 8.1 gives me 2.4 ohms. And that's how we do internal resistance and terminal velocity.